Day 11 of 90. Today we are building Python tools for OSINT web scraping. During penetration tests and red team engagements, scraping public web pages for emails, employee names, subdomains, and exposed metadata is usually the first phase before any active exploitation. We will build 4 tools today and then combine them into a recon workflow. Starting with email harvesting using BeautifulSoup and lxml. The key detail most tutorials skip is that you need to decompose script and style tags before running your regex extraction. Without that step, JavaScript variable assignments and CSS content properties generate false positive email matches that waste investigation time. I tested this on a page with heavy analytics tracking, and skipping the decompose step produced over 40 garbage matches from tracking pixel URLs. Our scraper uses requests to fetch the page, passes it through BeautifulSoup with the lxml parser for speed, removes noise elements, then runs a regex pattern across the clean text. We also parse Mailto links separately since some contact pages use those instead of displaying addresses as plain text. Next up is metadata extraction. Meta tags are a goldmine for OSINT because organizations frequently forget to strip internal information from production pages. The generator tag reveals CMS names and versions. Author tags expose employee names. Open graph tags leak internal URLs and asset paths. Our extractor pulls every meta tag with a name or property attribute and also maps all outbound links to identify connected infrastructure and third-party services. During a real engagement I ran this against a target careers page and found a generator tag showing they ran WordPress 4.9.8, which had multiple known vulnerabilities at the time. Now for Robots.txt analysis. Organizations list sensitive paths as disallowed, thinking search engine crawlers will respect the directive. But anyone can read Robots.txt. Our parser fetches the file, extracts every disallowed path, and checks each one against keywords like admin, login, dashboard, API, internal, staging, backup, and config. We also use the standard library robot file parser class to check fetch permissions programmatically. On a test target this script found 4 hidden paths including an admin dashboard and a staging API endpoint. Critical ethical point: discovering a path through Robots.txt does not authorize you to access it. Document the finding and confirm scope with your client. JavaScript-rendered content is the next challenge. Modern single-page applications built with React, Angular, or Vue load content dynamically. A plain requests.get call returns an almost empty HTML shell with bundled JavaScript files. For OSINT against these targets, we need a headless browser. I am using Playwright here. It launches headless Chromium, navigates to the target, waits for either a specific CSS selector or the network idle event, then dumps the fully rendered HTML. We pass that rendered HTML through BeautifulSoup just like before to extract employee names from staff directories, team pages, and about sections. Quick optimization tip: only use Playwright after confirming the target needs it. Check the view source first. If you see actual content in the raw HTML, stick with requests since it is 10 times faster. Let us tie everything together into a recon workflow. Our combined script runs Robots.txt analysis first to discover hidden paths, then extracts metadata from the main page, and finally harvests emails. Each phase prints progress, and the entire result gets saved as a timestamped JSON report. This structured output is important for professional engagements because you need an audit trail showing what you collected, when you collected it, and from which URLs. The report format also makes it easy to feed findings into downstream tools or generate client deliverables. That wraps day 11. We built a complete passive OSINT collection toolkit using BeautifulSoup, requests, Playwright, and the standard library robot parser. All of this stays within Passive reconnaissance boundaries, meaning we only read publicly available data without sending any payloads or exploiting vulnerabilities. The JSON report structure we built at the end is how professional engagements document their findings. Every request, every timestamp, every discovered artifact gets logged so you have a defensible audit trail when you deliver results to the client. Tomorrow on day 12 we move from passive scraping into active API enumeration, probing REST endpoints and mapping authentication schemes. See you then.